September 26, 1940, Mikhail Koshkin, creator of the legendary T-34 tank, passed away. The mission to continue the genius's work fell on the shoulders of his 35-year-old student, Alexander Morozov. Would the young designer be able to not only preserve his teacher's legacy, but also surpass it? The story of a tank builder who went from being a clerk to the creator of the tanks of the future, perfected the T-34, created the revolutionary T-44, T-54, and legendary T-64, ensuring the Soviet Union's technical superiority for decades to come. September 26, 1940, was a turning point in the history of Soviet tank building. Mikhail Ilyich Koshkin, the brilliant designer and creator of the legendary T-34 tank, died of a serious illness in the Kharkov Regional Hospital. He was only 41 years old. On his hospital bed lay a man who had managed to embody a revolutionary idea in metal: to create a tank capable of changing the course of future wars. But his main creation, the T-34 tank, was just beginning its journey to immortality. Who was able to continue Koshkin's work and bring his idea to perfection? This mission fell on the shoulders of 35-year-old Alexander Alexandrovich Morozov, Koshkin's closest associate and student. Morozov was the technical director of the T-34 project. He knew the machine from the first bolt to the last rivet. It was he who developed the transmission and running gear of the tank, and it was he who, together with Koshkin, traveled the legendary winter route from Kharkov to Moscow, proving the superiority of the new tank to the military leadership. Now, the fate of the entire project depended on him. Would the young designer be able to cope with the responsibility? Would he be able not only to preserve his teacher's legacy, but also to surpass it? The autumn of 1940 was a turbulent time. World War II was raging in Europe. Germany had defeated France and captured most of the continent. The Wehrmacht's tank wedges broke through the enemy's defenses, demonstrating the new blitzkrieg tactics. The Soviet Union was feverishly preparing for the inevitable clash with Hitler's machine. In these conditions, the question of which tanks would be used by the Red Army became a matter of life and death for millions of people. The T-34 had already been adopted, but mass production was still a long way off. It was necessary to refine the technology, eliminate design flaws, and establish the production of complex assemblies. Alexander Morozov understood the scale of the task perfectly well. He was not an armchair theorist. He had a wealth of practical experience behind him. Starting as a simple clerk at the Kharkov locomotive plant in 1919, he worked his way up to become a copyist, draftsman, and designer. He participated in the creation of the first Soviet Kommunar crawler tractors, worked on the T-24 tank, and developed the famous series of BT fast tanks. But the T-34 was a special project. It was a new generation machine, the embodiment of the most advanced ideas in world tank building. And now it was left without its main creator. The design bureau of plant number 183 in Kharkov was plunged into mourning, but there was no time for grief. Production of the T-34 was gaining momentum, and the first production vehicles began to roll off the assembly lines. However, military tests revealed shortcomings that required immediate correction. The transmission was not reliable enough, the gearbox failed, and mechanics and drivers complained about the difficulty of control. The tank's turret was cramped, and the commander had to combine many functions, which reduced combat effectiveness. The optics needed refinement, and the quality of the armor at some factories did not meet the requirements. Morozov had to solve these problems while preserving the main advantages of Koshkin's design. The factory management and the People's Commissariat for Armaments had no doubts about their choice. Morozov was approved as the chief designer of the Tank Design Bureau. He was given the title of technical director of the T-34 project. He was joined by a team of talented engineers: Nikolai Alexeyevich Kucherenko, Mikhail Ivanovich Tarshinov, and Alexander Vasilievich Bogatyrev. But it was Morozov who bore the brunt of the decision-making. Each of his decisions now affected the fate of thousands of tankers and the outcome of future battles. He understood that a mistake could cost the lives of his compatriots. Success, on the other hand, would pave the way to technical superiority over the enemy. Morozov did not change Koshkin's concept. He deeply believed in the correctness of the basic decisions: the sloped armor, the V2 diesel engine, the wide tracks, and the powerful 76mm gun. These decisions made the T-34 a revolutionary tank, unmatched anywhere in the world. The task was to perfect the design, eliminate all flaws, and make the tank reliable and technologically advanced in production. Morozov methodically set to work. He analyzed every report from the test sites, every comment from the tankers, every breakdown. Gradually, the design of the T-34 was improved, becoming more mature and combat-ready. But history did not allow time for hesitation. Less than a year remained before the start of the Great Patriotic War. Tank factories worked at full capacity, increasing the production of T-34s. By the summer of 1941, the Red Army had received more than 1,000 new tanks. This was a significant achievement, but not all of the vehicles had been perfected. Morozov worked day and night, knowing that a test lay ahead, for which it was impossible to be fully prepared. Would his tank live up to expectations? Would the Koshkin-Morozov design withstand the steel onslaught of the Panzerwaffe? Only the war that was about to begin would provide the answers to these questions. Alexander Morozov's path to the heights of Soviet tank building began in the small town of Bezitsa in the Oryol Governorate. On October 16, 1904, a boy was born here into a working-class family, a boy who was destined to create tanks that would define the face of armored forces for half a century to come. Bezhitsa was a typical industrial town of the Russian Empire, with factories, workers' barracks, and smoking chimneys. This is where locomotives and rail cars were made, where the character of the future builders of Soviet industry was forged. Alexander's childhood was spent in an atmosphere of factory whistles and the metallic clang of forges. But who could have guessed that this boy from a working-class family would become one of the greatest designers of the 20th century? In 1914, the Morozov family moved to Kharkov, a major industrial and cultural center of the Russian Empire. Here, Alexander went to a technical school where he received a basic technical education. But he did not have long to study. The revolution broke out, followed by the Civil War. The country was plunged into chaos, and many teenagers had to grow up early. At the age of 15, having completed only 6 years of school, Alexander began his working life. The year 1919 became for him a time of entering the world of big industry. The Kharkov locomotive plant, the largest enterprise in the city, opened its doors to the young Morozov. The position of clerk seemed modest, but it gave him the opportunity to be at the heart of production, to observe the work of engineers and designers, and to understand the logic behind the creation of complex mechanisms. Morozov was curious and determined. He spent every free minute in the drawing offices and workshops, studying the structure of locomotives, carriages, and machine tools. Gradually, the clerk became a copyist of drawings, then a draftsman. Each new position brought him closer to his cherished goal of becoming a real designer. Alexander learned on the job, absorbing knowledge like a sponge. His technical abilities did not go unnoticed. In the early 1920s, the Kharkov locomotive plant began to master a new product for itself: crawler tractors. The Soviet government had embarked on a course of industrializing agriculture, and the country needed thousands of tractors to replace horse-drawn power. The Kommunar tractor project was one of the first experiments in Soviet engineering in this field. The young Morozov had the opportunity to participate in the preparation of technical documentation for this machine. It was an invaluable experience working with tracked propulsion systems, transmissions, engines, everything that would later come in handy in tank building. Could he have imagined then that studying the design of a peaceful tractor would be the first step towards creating legendary combat vehicles? In 1928, Morozov was drafted into the Workers' and Peasants' Red Army. He was assigned to an aviation brigade, where he served as an aircraft mechanic. This service gave him new knowledge in the field of engines, mechanics, and the technical operation of complex equipment. Alexander learned not only to design mechanisms, but also to understand how they work in real conditions, what problems arise during operation, and how the equipment behaves in the hands of ordinary soldiers. This understanding would become one of his main advantages as a designer. He always designed machines not for exhibitions, but for the front, for real war, where reliability is more important than external glamour. After returning from the army, Morozov got a job as a designer at his native factory, and at the same time enrolled in the correspondence department of the Lomonosov Moscow Mechanical and Electrical Engineering Institute. In 1930, the institute was reorganized into the Moscow Automobile and Tractor Institute. Morozov studied hard, combining work and study. He understood that without a systematic engineering education, it was impossible to create truly advanced designs. A diploma from the institute opened the door to large projects, and such projects were already appearing on the horizon of the Soviet defense industry. The country set a course to create powerful armored forces capable of resisting any aggressor. In the late 1920s, the Kharkov locomotive plant received a defense order to master the production of tanks. From that moment on, Morozov's fate was sealed. He joined the team developing the first Soviet medium tank, the T-64. He was only 27 years old when mass production of the vehicle created by his design department began. The T-24 did not become a mass-produced tank. It was considered too complex and expensive, but it gave invaluable experience to young Soviet tank builders. Morozov studied the design of tanks from the inside, understanding their strengths and weaknesses. He saw how theory turned into metal, how drawings became combat vehicles. From 1931, Morozov's main focus was on a series of light, fast-moving BT wheeled tracked tanks. These vehicles were developed on the basis of the American Christie tank, but Soviet designers modified them significantly. The BT-2, BT-5, and BT-7 tanks became the backbone of the Red Army's armored forces in the 1930s. Morozov was responsible for designing the transmission and running gear of these vehicles. He became a true expert in this field. In 1934, Alexander even completed a course for BT tank commanders to better understand how the vehicle performed in operation, what tank crews needed, and what problems they encountered. This unusual step, a designer himself sitting at the controls of his brainchild, demonstrated the depth of Morozov's approach to his work. By the mid-1930s, Alexander Morozov had become one of the leading specialists in the factory's design bureau. In 1936, he headed the new design sector. His career seemed to be going brilliantly, but then the Great Terror burst into the life of the design bureau. The management of the factory and the design bureau were repressed for technical defects in the BT-7 tanks. Accusations of sabotage and vandalism were leveled at the talented engineers. An atmosphere of fear paralyzed the work. In this critical situation, a new chief designer, Mikhail Koshkin, who had previously worked at the Leningrad-Kirov plant, was sent to Kharkov. The meeting between Koshkin and Morozov was fateful for Soviet tank building. But what trials awaited them ahead? Mikhail Koshkin arrived in Kharkov in 1937, at the height of the repressions. The situation at the plant was dire. Chief designer Afanasy Osipovich Firsov and a number of leading specialists had been arrested. The work of the design bureau was practically paralyzed. The staff was frightened, and many were afraid to show initiative. In such conditions, a leader with an iron will was needed, someone capable of both organizing the work and protecting people from unfounded accusations. Koshkin turned out to be just such a person. The 42-year-old designer, with vast experience working at the Leningrad-Kirov plant, quickly assessed the situation and began to restore normal operations. He sought out talented people in the team who could be entrusted with responsible areas of work. One of the first to catch his attention was Alexander Morozov. Koshkin quickly assessed Morozov's professionalism and technical abilities. The 33-year-old designer knew the plant inside out, had vast experience working with BT tanks, and understood the production capabilities of the enterprise. At the same time, Morozov was not involved in the production conflicts and technical failures that served as grounds for repression. Koshkin appointed him as his deputy for the design of the running gear and transmission. This was a key position, as these components determined the mobility and reliability of the tank. The two designers established a relationship that could be described as teacher-student, even though the age difference between them was only 9 years. Koshkin generously shared his experience, and Morozov eagerly absorbed the knowledge. Together, they formed a surprisingly effective team. The first major project that Koshkin and Morozov began to develop together was the A-20 wheeled tracked tank. The task came from the main armored directorate of the Red Army to create a new light, fast-moving tank capable of replacing the outdated BT-7. The tank had to be able to reach high speeds on wheels on roads and move confidently on tracks off-road. The requirements were strict: anti-shell armor, powerful weapons, reliability, and manufacturability. Morozov was responsible for developing the running gear with individual torsion bar suspension, which was a cutting-edge technical solution at the time. Work was proceeding intensively, but Koshkin had doubts about the correctness of the very concept of a wheeled tracked tank. Mikhail Ilyich was increasingly inclined to believe that the future belonged to purely tracked vehicles. Wheeled suspension complicated the design, increased weight, and reduced reliability. On the battlefields of the future war, tanks would have to operate off-road, ford rivers, and storm fortifications. In such conditions, wheeled suspension was useless. Abandoning them would allow for stronger armor, improved cross-country mobility, and a simpler transmission. Koshkin convinced the leadership of the need to simultaneously develop a purely tracked version of the tank, which was given the index A32. Morozov ardently supported this idea. He understood that by creating the A32, they were in fact designing the tank of the future, a new generation of vehicle. The work was carried out in a climate of fierce competition. The Kharkov A-20 was pitted against the Leningrad SMK project and the multi-turret T-100. In May 1939, the A-20 and A-32 prototypes were ready for testing. A dramatic struggle for the future of Soviet tank building began. Officially, the order was for the A-20, but Koshkin insisted on comprehensive testing of the A-32. The vehicles underwent field tests at the Kubinka Proving Ground near Moscow. The A-32 performed brilliantly, demonstrating excellent mobility, high cross-country capability, and powerful armor. The sloped armor plates significantly increased the tank's resistance to shelling. The V2 diesel engine, developed by Kharkov Plant No. 75, provided excellent dynamic characteristics and was fire-safe, unlike gasoline engines. The 76mm L11 gun, designed by Plant No. 92, gave the tank powerful armament. Morozov personally participated in all tests, made adjustments to the design, and eliminated identified shortcomings. He stood guard near the machines for days on end, delving into every detail. The torsion bar suspension worked perfectly, ensuring a smooth ride and survivability. Wide tracks provided low ground pressure, which ensured passability on snow and mud. But the military commissions remained conservative. They were accustomed to the wheel track design of BT tanks and were in no hurry to abandon it. More convincing evidence was needed. And then Koshkin proposed an incredible plan: to send both tanks on a journey from Kharkov to Moscow in winter, through snow and off-road, to demonstrate their capabilities to the country's top leaders. It was a risky move, but there was no other way to break through the wall of conservatism. In March 1940, the legendary epic began. Two tanks, the A-20 and A-32, set off on the winter roads of Ukraine. The convoy was accompanied by a group of designers and testers. Morozov was among them. The tanks moved under their own power, covering hundreds of kilometers across snow-covered virgin soil, through rivers and ravines. These were not ceremonial tests on asphalt, but a real test in combat, or rather, what awaits tanks in real war. The A-32 performed confidently, confirming all its advantages. The A-20, with its wheel-tracked design, experienced more problems off-road. After the demonstration in Moscow to the country's leadership, headed by Stalin, the tanks set off on their return journey. The 1,750-kilometer journey was a triumph for the new design and a personal feat for its creators. But this victory came at a high price for Koshkin. During the journey, he caught a cold and became seriously ill. The inflammation of his lungs developed into bilateral pneumonia. Despite his illness, Mikhail Ilyich continued to work, pushing for the A-32 to be adopted for service. On December 19, 1939, the tank, designated T-34, was officially adopted by the Red Army. It was Koshkin's greatest victory, but his health was irrevocably undermined. In the spring of 1940, his illness worsened dramatically. Morozov saw his teacher fading away, but there was nothing he could do to help. There was only one thing he could do: work on improving the T-34, bringing its design to the level that Koshkin had dreamed of. And when Mikhail Ilyich passed away on September 26, 1940, Morozov promised himself that he would continue his teacher's work and see it through to the end. But could he handle this task alone? The winter march of 1940 from Kharkov to Moscow and back went down in the history of Soviet tank building as one of the most daring and successful experiments. Alexander Morozov was not just a witness to this event. He was a direct participant and one of its main organizers. On March 5, 1940, two tanks, the A-20 and A-32, left the factory gates in Kharkov and headed north. Officially, it was called a military test, but in reality, it was a desperate attempt by Koshkin to prove the superiority of the new design to the country's top leaders. Morozov understood the full extent of the risk. If the tanks broke down on the way, if they failed to live up to expectations, the project could be buried. But he believed in his design as much as Koshkin did. The convoy moved along the winter roads of Ukraine and Russia at maximum speed. Morozov rode in one of the escort vehicles, constantly monitoring the condition of the tanks and analyzing the operation of all components and assemblies. Each stop turned into a mini-seminar. The designers inspected the running gear, checked the transmission, engine, and tracks. The Torsian suspension designed by Morozov performed excellently. The wide tracks held the vehicle steady even in deep snow. The A-32 drove across virgin soil where ordinary wheeled vehicles would get hopelessly stuck. This was clear proof that the chosen concept was correct. The wheeled-tracked A-20 performed worse. Its complex transmission suffered from overloads, and its wheeled travel on snow was practically useless. One of the most dramatic moments of the run was the crossing of rivers. The tanks had to wade through water obstacles, demonstrating their amphibious qualities. Morozov watched with excitement as the vehicles entered the icy water. The V2 engine ran smoothly, the transmission held the load, and the tracks clung to the bottom. The water rose to the turret, but the tank continued to move. It was an impressive sight, a multi-ton steel machine confidently moving along the river bottom like a submarine. The crew inside was relatively safe thanks to the well-designed sealing of the hull. When the tank reached the opposite bank, Morozov felt a huge sense of relief. Another test had been successfully completed. On March 17th, the convoy reached Moscow. The tanks drove through the streets of the capital and were presented to the highest military and political leadership of the USSR. The demonstration took place in a closed area. Joseph Vissarionovich Stalin, Kliment Yefremovich Voroshilov, other members of the Politburo, and the highest military command were present. Koshkin personally reported on the characteristics of the machines and answered questions. Morozov was nearby, ready to provide any technical explanations. Stalin carefully examined both tanks, climbed onto the armor, and looked inside the turret. He was interested in the details, the thickness of the armor, the power of the weapons, the reliability of the engine, and the manufacturability. The questions were tough and specific. The country's leader understood that a tank was not a toy for parades, but a weapon that had to win the war. The slope of the A-32's armor plates attracted particular attention. It was a revolutionary solution. Instead of the vertical armor arrangement typical of most tanks of the time, Koshkin and Morozov used rational angles of inclination. This design significantly increased shell resistance without increasing the thickness of the armor. A shell hitting an inclined surface was likely to ricochet without penetrating the metal. This meant that the relatively thin but correctly positioned armor of the A-32 was equivalent to much thicker vertical armor. The weight savings made it possible to strengthen the armament and improve mobility. Morozov proudly explained these advantages to military specialists. Not everyone immediately understood the genius of the solution, but the results of calculations and firing tests were convincing. After the Moscow demonstration, it was possible to return to Kharkov by rail on flat cars, but Koshkin insisted on driving back under his own power. He wanted to prove once and for all the reliability and endurance of his brainchild. Morozov supported this decision even though he understood the risks. The tanks set off again, covering hundreds of kilometers of snow-covered roads. The return journey was no less difficult than the trip to Moscow. The vehicles drove through forests and fields, forded rivers, and crossed ravines. With every kilometer traveled, Morozov became more and more convinced of the correctness of his design decisions. The running gear withstood enormous loads, the engine ran smoothly, and the transmission did not fail. Of course, there were problems. Individual parts wore out, mechanisms needed adjustment, but these were solvable technical issues, not fundamental design flaws. The total mileage was 1,950 kilometers. For tanks of that era, this was a fantastic figure. The vehicles covered this distance in March, the most difficult time of year, when the roads are muddy from melting snow and the rivers break up from the ice. They did not travel on paved highways, but on dirt roads, across virgin soil, through forests and swamps. It was a real test of strength, reliability, and survivability. And the Koshkin-Morozov tank passed this test with flying colors. After returning to Kharkov, the military commission gave a positive conclusion. The path to mass production was open. On December 19, 1939, even before all the tests were completed, the Defense Committee under the Council of People's Commissars of the USSR adopted a resolution to adopt the T-34 tank into service. It was a victory, but at what cost? During the test run, Mikhail Koshkin caught a bad cold. He rode in an open car in the bitter cold, wet and frozen, inspecting tanks at parking lots, sparing no effort for the sake of the cause. His body could not withstand such stress. The inflammation of his lungs progressed rapidly. Morozov watched with horror as his teacher grew weaker. But Koshkin did not stop working. He supervised the preparation of serial production, made the final changes to the drawings, and resolved organizational issues. It was as if he sensed that time was running out and was rushing to do everything he could. Morozov tried to help, to lighten his teacher's load, but Mikhail Ilyich was stubborn and did not want to delegate key decisions. He had created the T-34, and he wanted to see it through to the end. But fate had other plans. Koshkin's death in September 1940 presented Morozov with a task for which it was impossible to prepare in advance: to continue the work of a genius alone. The death of Mikhail Koshkin on September 26, 1940, was a heavy blow to the entire design team at Plant Number 183. The man who created the tank of the future did not live to see the start of the war for which this tank was intended. He was only 42 years old. Decades of fruitful work, new projects, and new victories could have been ahead of him. But fate dealt a cruel blow. Alexander Morozov lost not only his boss, but also his friend, mentor, and kindred spirit. Their collaboration lasted only 3 years, but during that time, they managed to create a machine that would go down in history as one of the best tanks of World War II. Now, all responsibility for the fate of the T-34 fell on the shoulders of the 35-year-old Morozov. Would he be able to justify the trust placed in him? Would he have enough strength, experience, and authority to lead the team? The leadership of the People's Commissariat for Armaments and the factory management had no doubts about the choice of Koshkin's successor. Morozov was his closest associate. He knew the T-34 project from the first bolt to the last rivet. He was the one who developed the tank's running gear and was responsible for the transmission. He participated in the tests, in the legendary run to Moscow, and in the finalization of the design. He was respected by both engineers and workers. Morozov was appointed chief designer of the Tank Design Bureau at Factory Number 183. Along with this appointment came an avalanche of problems. The T-34 was accepted into service, but the design was still far from perfect. Military tests revealed one flaw after another. Factories that were mastering the production of the tank faced technological difficulties. One of the main problems remained the transmission. The T-34's gearbox was difficult to operate and not reliable enough. Mechanics and drivers complained about the stiffness of the gear shift levers. Shifting gears required considerable physical effort, sometimes even hitting the levers with a hammer. This was unacceptable in combat conditions. In addition, the gearbox often broke down, unable to withstand the loads. Morozov understood that a radical modernization of the transmission was needed, but this would take time, and time was the most scarce resource. He began working on an improved gearbox, while at the same time refining the serial design, making it at least a little more reliable and convenient. Every little detail mattered, changing the shape of the gear teeth, improving lubrication, strengthening individual parts. Another problem was the cramped combat compartment. The T-34 turret was designed for two people, the tank commander and the loader. At the same time, the commander had to perform the functions of a gunner, that is, simultaneously command the tank, monitor the situation, and fire the cannon and coaxial machine gun. This led to a decrease in combat effectiveness. In German tanks of the same class, the turret crew consisted of 3 people: the commander, the gunner, and the loader. The commander could focus entirely on directing the battle. Morozov understood this problem, but it was impossible to solve it within the existing design. A new, more spacious turret was needed. Work on a 3-man turret began, but it would take months to complete, and war was already on the horizon. The quality of the armor was also a cause for concern. Not all factories supplying armored steel met the required metal specifications. The armor could be brittle and crack when fired upon. This meant that even without penetrating the armor, a shell could cause a chip on the inside, hitting the crew with shrapnel. Morozov demanded that metallurgists improve the quality of the armor and tighten production controls. He personally visited metallurgical plants, met with technologists, and sought to raise standards. It was painstaking, exhausting work, far from the romance of design, but extremely necessary. The lives of tank crews depended on the quality of the armor. The tank's optics needed improvement. The visibility from the T-34 was unsatisfactory. The driver had a limited field of view through the observation hatch in the front plate of the hull. The tank commander, who also served as the gunner, had to observe through the sight and the commander's periscope. This was not enough to fully control the situation. Morozov worked on improving the observation system, but much depended on related industries, namely the factories that produced optics. The quality of Soviet tank sights was inferior to that of German ones. This was a fact that had to be taken into account. Morozov demanded that at least the reliability and durability of optical devices be ensured and that they be protected from damage. Despite all the problems, T-34 production was gaining momentum. By the summer of 1941, more than 1,100 tanks had been produced. This was a lot, but clearly not enough to arm all the tank units of the Red Army. The tank fleet was still based on light T-26 and BT tanks of various modifications, as well as heavy multi-turret T-35 and new KV tanks. T-34 tanks were delivered to the troops, and tank crews were trained on the new vehicles. The reviews were mixed. On the one hand, everyone recognized the power of the T-34's weapons and the reliability of its armor. On the other hand, there were complaints about the complexity of its controls, poor visibility, and the cramped combat compartment. Morozov carefully analyzed every review and every comment. He understood that his tank would only receive a real evaluation in battle. On June 22, 1941, the Great Patriotic War began. Germany launched a monstrous attack on the Soviet Union. Wehrmacht tank groups broke through the defenses, surrounded entire armies, and rushed deep into Soviet territory. The Red Army suffered heavy losses, but in the chaos of the first weeks of the war, reports began to appear that gave cause for hope. The T-34 tanks that entered the battle showed remarkable effectiveness. German anti-tank guns could not penetrate their armor. The T-34's 76mm gun destroyed any German tank from a distance at which they could not respond. The T-34's mobility and cross-country capability surpassed that of the enemy's vehicles. The Soviet tank turned out to be an unpleasant surprise for the Wehrmacht. German generals demanded urgent measures to strengthen anti-tank defenses. But there were not enough T-34s, catastrophically few. Morozov received information about the combat use of his tank. This was invaluable feedback. He understood that the design as a whole had been successful, and the tank had passed the test of war. But more vehicles had to be built, identified shortcomings had to be eliminated, and the design had to be improved. And all this had to be done in the midst of a war that had just begun. In the middle of the summer of 1941, it became clear that Kharkov was under threat. German troops were pushing eastward. Plant number 183 had to be evacuated. A massive operation to relocate production to the deep rear began. Morozov had to not only maintain T-34 production, but also organize it in a new location. It was a task that seemed impossible, but there was no alternative. The tanks were as essential to the front as air, and Morozov accepted the challenge. July 1941 was a month of great trials for Soviet industry. German troops were rapidly advancing eastward, capturing one industrial center after another. Kharkov, Ukraine's largest industrial city and a center of tank production, was under threat. Factory number 183, named after the Comintern, was the main manufacturer of T-34 tanks. The loss of this enterprise would have been a disaster for the country's defense capabilities. The State Defense Committee decided to evacuate the factory to Nizhny Tagil in the Urals. It was a huge operation. It was necessary to transport unique equipment, technological tools, drawings, materials, and most importantly, people capable of setting up production in a new place, thousands of kilometers away. Alexander Morozov was tasked with ensuring the continuity of T-34 production during the evacuation. It seemed almost impossible. The evacuation began in mid-September 1941. Trains carrying equipment, materials, workers, and engineers moved eastward by rail. Morozov supervised the dismantling and packing of the design bureau. All technical documentation, drawings, calculations, and experimental equipment had to be removed. Every day counted. The Germans were approaching Kharkov. The city was periodically bombed. Work was carried out in emergency mode, day and night. Workers and engineers labored to exhaustion, understanding that every machine tool and every drawing taken to the east brought victory closer. Morozov hardly slept, coordinating the actions of dozens of teams and resolving hundreds of organizational issues. He had to not only move the design bureau, but also ensure that work could continue in the new location. The journey from Kharkov to Nizhny Tagil took more than 2 weeks. The railway network was overloaded with evacuation trains. The trains moved slowly, often stopping to let military trains pass. The carriages were filled with people and their families, carrying their meager belongings. Many were leaving their homes forever, not knowing what lay ahead. Morozov traveled in one of the trains, constantly keeping in touch with other groups of evacuees. He made plans for the placement of equipment in the new location, thought through technological processes, and resolved personnel issues. The Ural Carriage Works, which was to become the base for the evacuated production, was located in Nizhny Tagil. The task was to unite 2 teams, harmonize traditions and working methods, and create a single enterprise. Nizhny Tagil greeted the evacuees with a harsh autumn. The cold weather was setting in, and the production buildings were not ready to accommodate the new equipment. Some of the equipment had to be installed in the open air, under temporary sheds. Workers and engineers lived in hastily equipped barracks, in extremely difficult living conditions. There was a shortage of food, fuel, and warm clothing. But there was no time to settle in. The front needed tanks. Every day of delay meant lost lives at the front. Morozov mobilized all his authority and organizational skills to get the T-34 production up and running in the new location as quickly as possible. He worked 18 to 20 hours a day, solving endless problems, settling conflicts, and delving into the smallest details of the production process. The first tank at the Ural Vagonzavod was assembled on December 27, 1941, just 3 months after the evacuation began. It was a victory of the human spirit, a triumph of Soviet production organization. Under normal conditions, it would have taken years to build a tank factory from scratch. Here, it was done in 3 months, in wartime conditions, in winter, in the Urals. Morozov personally accepted the first vehicle, checking every component, every connection. The tank was not as high quality as the Kharkov vehicles. The untested technology, the lack of skilled workers, and problems with the supply of components all had an impact. But the tank was there, and it could fight. And that meant the most important thing had been achieved. In the first months of work at the new location, tank production was low, only a few vehicles per day. But with each passing week, production gained momentum. The technology was refined, new workers were trained, and relationships with suppliers were established. Morozov simultaneously managed production and continued design work to improve the T-34. He analyzed information from the front, studied reports on the combat use of tanks, and made changes to the design. The war showed that the T-34 surpassed all German tanks in terms of overall characteristics, but it had shortcomings that needed to be addressed. The main one was the insufficient firepower against the new German heavy tanks that began to appear on the front. In the fall of 1942, the first German Tiger heavy tanks appeared on the Eastern Front, equipped with an 88mm gun and powerful frontal armor. The T-34's 76mm gun could not penetrate the Tiger's frontal armor from a safe distance. This was a serious problem. Morozov understood that the T-34's armament needed to be upgraded. Work began on installing a more powerful 85mm gun on the tank. But this required the design of a new, more spacious turret. The task was difficult. It was necessary to preserve the main advantages of the T-34, its mobility and manufacturability, while radically increasing its firepower. Morozov immersed himself in the design of the modernized tank. In parallel with his work on the T-34, Morozov began to think about a promising next-generation medium tank. Combat experience showed the direction in which tank construction was heading. More powerful armor, a more sophisticated transmission, improved visibility, and increased reliability were required. Morozov made sketches, calculated layout options, and discussed ideas with colleagues. These were only preliminary studies, but they laid the foundation for future projects. The war was raging, and T-34s were fighting on all fronts, earning a reputation as the best medium tank of World War II. But Morozov was already thinking about the future, about the tanks that would replace the T-34. He understood that a designer must work ahead of the curve, creating the technology of tomorrow. And that day was approaching. The year 1942 became a time for reflecting on combat experience and systematically modernizing the T-34. Alexander Morozov had the opportunity to analyze hundreds of reports from the front, talk to tankers, and study damaged and destroyed vehicles. The picture that emerged was contradictory. On the one hand, the T-34 confirmed its outstanding qualities. Its sloped armor reliably protected the crew from most German anti-tank weapons. Its 76mm F-34 gun destroyed German tanks at distances of over 1,000 meters, and the mobility and cross-country ability of the Soviet vehicle surpassed that of the enemy's equipment. On the other hand, serious shortcomings became apparent, many of which Morozov had anticipated even before the war, but did not have time to eliminate due to a lack of time and resources. Now, it was time to correct these shortcomings, and to do so directly during serial production, which made the task many times more difficult. One of the most acute problems remained the reliability of the transmission. The T-34 gearbox of the 1941-1942 model was the Achilles heel of the vehicle. It required considerable physical effort from the driver when shifting gears and often broke down, especially when operated by inexperienced crews. Morozov understood the root of the problem perfectly well. The transmission, designed back in the late 1930s, was not designed for the increased weight of the tank and the increased combat loads. A radical redesign was required. Engineers led by Morozov developed several versions of an improved gearbox. Tests showed that the new solutions did indeed increase reliability and make the tank easier to control. But introducing the improved transmission into serial production required a reorganization of technology, the manufacture of new equipment, and the training of workers. It was a difficult compromise between what was desired and what was possible. The visibility problem also needed to be solved. Tank crews complained about poor visibility from the tank, especially the driver. The observation hatch in the front plate of the hull provided a limited field of view, and in combat situations, it had to be closed with an armored shutter, which further impaired visibility. The driver could only observe the terrain through a narrow observation slit, which made driving difficult, especially in rough terrain. Morozov worked on improving the observation system. New periscopic observation devices were developed and installed in the driver's hatch cover. These devices provided better visibility when the hatch was closed and increased the safety of the crew. The new observation devices were introduced gradually as they became available. Despite the revolutionary concept of sloped armor plates, the T-34's armor also had vulnerable spots. The sides of the tank were relatively thin, 45mm, and were positioned vertically. German 50mm anti-tank guns could penetrate the T-34's side armor at close range. This made the tank vulnerable to flank attacks. Morozov considered the possibility of strengthening the side armor, but this would have increased the tank's weight and reduced its mobility. A reasonable compromise was needed. It was decided to keep the thickness of the side armor, but improve the tactics of using tanks, taking advantage of their mobility to avoid flank attacks. In addition, additional fuel tanks began to be installed on the tank on the track shelves, which served as shielding protection for the upper part of the side. The quality of tank manufacturing under evacuated production conditions was lower than before the war. This was inevitable. Inexperienced workers were employed. There was a shortage of skilled specialists, and production was carried out at a frantic pace. Morozov fought to improve quality by all means available. He tightened control over key operations, sought to improve the quality of supplied components, and introduced more advanced technological processes. Gradually, the quality of the tanks improved. By mid-1943, the Ural T-34s had almost caught up with the pre-war Kharkov machines in terms of reliability. This was a great victory, achieved through the hard work of thousands of workers and engineers. By 1943, the T-34's armament had begun to lag behind the requirements of the time. The appearance on the front lines of German Tiger heavy tanks and Panther medium tanks with powerful frontal armor called into question the effectiveness of the 76mm F-34 gun. Although this gun could penetrate the Tiger's armor at close range when hitting the side or rear, the Tiger was virtually invulnerable to the T-34 at distances of more than 500 meters. The Panther, with its sloped frontal armor 80 millimeters thick, also posed a serious problem. Morozov understood that the T-34's armament needed to be upgraded urgently. The choice fell on the 85mm anti-aircraft gun of the 1939 model, which had proven highly effective when firing at ground targets and had powerful ballistic characteristics. Installing an 85mm gun on the T-34 required the design of a new turret. The old two-man turret was too cramped to accommodate a larger gun and its ammunition. Morozov decided to create a fundamentally new three-man turret with an increased diameter. This not only allowed for the installation of a more powerful gun, but also solved the long-standing problem of the tank commander's overload. Now the turret could accommodate three people: the commander, the gunner, and the loader. The commander could focus on directing the battle, the gunner on accurate firing, and the loader on quickly feeding shells. This dramatically increased the tank's combat effectiveness. The new turret was designed with casting technology in mind. It was planned to be manufactured using cast armor steel, which simplified production and accelerated the release of vehicles. Work on the modernized T-34-85 proceeded at a rapid pace. It was necessary not only to design a new turret, but also to coordinate it with the existing hull, develop the production technology, conduct tests, and set up serial production. Morozov coordinated the work of several design bureaus and factories. The gun was developed by the Design Bureau of Factory No. 92 in Gorky, while the turret was designed by several organizations simultaneously. Morozov was responsible for the overall layout of the vehicle and the coordination of all changes. By the end of 1943, the T-34-85 prototypes were ready for testing. The results exceeded expectations. The tank retained all the advantages of the base model, while receiving significantly more powerful armament and improved ergonomics in the fighting compartment. The path to serial production was open. January 1944 marked the start of mass production of the T-34-85, a deeply modernized version of the legendary tank. Alexander Morozov completed the work that Mikhail Koshkin had begun. The T-34 was equipped with powerful weapons capable of competing on equal terms with the German Tigers and Panthers. The 85mm ZISS-53 gun could penetrate the frontal armor of a Panther from a distance of 1,000 meters and the side armor of a Tiger from 1.5 kilometers. This radically changed the balance of power on the battlefield. Soviet tankers received a vehicle that could destroy enemy heavy tanks without exposing themselves to their deadly fire. The new three-man turret solved the problem of the tank commander being overloaded. Now the crew worked as a single unit. The commander directed the battle, the gunner fired accurately, and the loader ensured a high rate of fire. The combat effectiveness of the T-34 increased significantly. Externally, the T-34-85 differed significantly from the base model. The new turret had a larger diameter, 1,600 mm instead of 1,420 mm. It was made by casting armored steel, which simplified production. The turret had a streamlined shape with rational angles of inclination of the armored surfaces. A commander's cupola with a circular view was installed on the roof of the turret, which greatly improved the tank commander's situational awareness. He could observe the battlefield through 5 periscopic devices without opening the hatch. This increased the safety and effectiveness of tank control in battle. Morozov carefully thought through every detail of the new turret, taking into account the combat experience of previous modifications. The tank's hull remained virtually unchanged. This was a conscious decision by Morozov to retain the proven and technologically advanced design that had been tested in thousands of battles. It had the same sloped frontal armor 45 millimeters thick at an angle of 60 degrees, equivalent in strength to 90 millimeter thick vertical armor. It had the same reliable sides, the same running gear with 5 road wheels per side and torsion bar suspension, the same V234 diesel engine with a capacity of 500 horsepower, providing a speed of up to 55 kilometers per hour. The continuity of the design made it possible to quickly establish serial production of the T-34-85 at all factories producing the base model. This was critically important. The front demanded tanks in huge quantities. The tank's weight increased to 32 tons, 1.5 tons more than the T-34-76. This was the price to pay for a heavier turret and more powerful armament. But the engine coped with the increased load, and the tank's mobility remained high. Moreover, the improved transmission, which Morozov introduced in parallel with the new turret, made the tank easier and more reliable to control. Mechanics and drivers noted that the T-34-85 handled significantly better than earlier modifications. Shifting gears required less effort, and the transmission worked more smoothly. This was the result of the painstaking work of Morozov and his team on improving the transmission. The war forced them to do what would have taken years in peacetime. The tank's ammunition load consisted of 60 rounds for the 85mm gun, which was less than the 77 rounds carried by the T-34-76, but this was compensated for by the greater effectiveness of each shell. The BR-365 armor-piercing shell could penetrate 100 mm of vertical armor at a distance of 1,000 meters. The O-365K high-explosive fragmentation shell was highly effective against unarmored targets and infantry. The BR-365P subcaliber shell could penetrate 140 millimeters of armor, but was in short supply and was issued to crews for use against specially protected targets. Morozov insisted on the development of more effective ammunition, understanding that the shell was just as important as the gun. Work was carried out in several directions simultaneously. The first T-34-85s saw combat for the first time in the spring of 1944. The tank crews' reviews were enthusiastic. Finally, they had a vehicle capable of confidently fighting German heavy tanks at medium ranges. It was no longer necessary to risk their lives by getting close to the Tiger in order to hit it in the side. Now it was possible to fight at a distance of 1,200 meters, using the advantage of mobility to maneuver and take up advantageous positions. The T-34-85 quickly won the love of the crews. A spacious turret, comfortable workstations, good visibility, and powerful armament all made the tank an effective combat tool. Morozov received letters of gratitude from tankers, and this was the best reward for the designer. By the summer of 1944, the T-34-85 had become the main medium tank of the Red Army. Production was in full swing, with factories producing hundreds of vehicles every month. Tank brigades and corps were re-equipped with the new model. The T-34-85 participated in the largest operations of 1944, the liberation of Belarus, the Lviv-Sandomierz offensive, and the breakthrough into Romania. It proved highly effective everywhere. The German command was forced to admit that Soviet tanks had regained their technical superiority. The T-34-85 became a symbol of the Red Army's offensive power. But for Alexander Morozov, this was not the end, but an intermediate stage. He was already working on the next generation of tanks, a machine that was to surpass the T-34 just as it had surpassed the tanks of the 1930s. This new tank was given the index T-44. In parallel with his work on the T-34-85, Alexander Morozov was developing the idea of a fundamentally new medium tank. Combat experience showed that the T-34, even in its modernized version, was approaching the limits of its capabilities. Further strengthening of armor and armament would require a radical redesign. Morozov understood that a next-generation tank was needed, embodying all the achievements of Soviet design thinking. This tank had to retain the best qualities of the T-34, mobility, reliability, and manufacturability, while surpassing it in terms of protection and firepower. In early 1943, design work began on a vehicle designated the T-43, but it soon became clear that more radical solutions were needed. This led to the T-44 project, a tank that revolutionized the layout of combat vehicles. The key idea behind the T-44 was the transverse engine layout. Previously, all Soviet tanks had their engines mounted longitudinally along the hull. This was a traditional layout that had been proven over decades. However, it had a significant drawback. It required a long engine compartment, which increased the overall length and weight of the tank. Morozov proposed a radical solution: to rotate the V-44 engine 90 degrees and install it across the hull. The engine's crankshaft was positioned perpendicular to the tank's longitudinal axis. This made it possible to significantly reduce the length of the engine compartment, decrease the dimensions of the hull, and lower the weight of the vehicle. The freed-up weight could be used to reinforce the armor. The idea seemed simple, but its implementation required solving a number of complex technical problems. The transverse arrangement of the engine required the creation of a fundamentally new transmission. The rotation of the crankshaft had to be transmitted to the drive wheels located at the rear of the tank. Morozov designed a complex transmission system that included a gearbox with 5 forward speeds and 1 reverse speed, side clutches, and planetary steering mechanisms. The transmission layout was very compact, with every cubic centimeter of the engine compartment used as efficiently as possible. Engine cooling also required new solutions. Radiators were placed on the sides of the engine compartment, and cooling air was supplied through louvers in the hull roof. The entire cooling system was redesigned to accommodate the changed layout. The reduction in hull length made it possible to radically strengthen the armor without increasing the tank's weight. The T-44's frontal armor reached 90 mm at a 60-degree angle, which was equivalent to 180 mm of vertical armor. Such protection made the tank invulnerable to most German anti-tank guns at distances of over 500 meters. The side armor was reinforced to 75 mm at the top and 45 mm at the bottom. The turret was the same as on the T-34-85, with an 85 VD gun. Morozov planned to install a more powerful 100 mm gun on the T-44 in the future, but for now, the priority was to work out the new hull layout and establish serial production. The T-44's running gear also underwent changes. Morozov used a torsion bar suspension with longer torsion bars, which improved ride comfort. The number of road wheels remained the same, 5 per side, but they had a larger diameter. The same tracks were used as on the T-34-85, which simplified the supply of spare parts. The drive wheels were located at the rear, and the guide wheels at the front. This layout was classic for Soviet tank design. The tank's ground clearance was 425 mm, which provided excellent cross-country ability. The wide tracks gave a low ground pressure of less than 0.8 kg per square centimeter. The T-44 could drive through snow and swamps where heavier vehicles got stuck. The T-44 weighed 31.8 tons, slightly more than the T-34-85, but with significantly reinforced armor. It was a triumph of rational design. The 500 horsepower V-44 engine provided a maximum speed of up to 60 kilometers per hour on the highway. The fuel range was 300 kilometers. The tank crew consisted of 4 people: a driver mechanic in the control compartment, a commander, a gunner, and a loader in the turret. The tank was lower than the T-34-85, measuring 2 meters 45 centimeters versus 2 meters 74 centimeters. This reduced the vehicle's visibility on the battlefield and made it more difficult for the enemy to detect. Every characteristic of the T-44 indicated that this was a new generation tank. The first prototype of the T-44 was manufactured in January 1944. Testing began immediately. Morozov personally supervised each stage. The tank performed excellently: high mobility, excellent cross-country ability, and reliable operation of all systems. The transverse engine layout, which had raised doubts among many experts, proved its effectiveness. The transmission, despite its complex design, worked reliably. The reinforced armor withstood fire from German guns. The T-44 passed all tests successfully. But the war was already coming to an end, and production of the T-34-85 was well established, supplying the front with hundreds of tanks every month. The Supreme Command decided not to restructure production and to continue manufacturing the T-34-85 until the end of the war. The T-44 was to become a post-war tank, a machine of a new era. The T-44 embodied a whole range of technical innovations, each of which was the result of a thorough analysis of combat experience and bold engineering thinking. Alexander Morozov did not simply modify the T-34, he created a tank based on a fundamentally new design philosophy. Every component, Every detail of the T-44 was rethought in terms of maximum efficiency of mass and volume. The tank's layout became the benchmark for rationality. The transverse engine layout was only the most noticeable of many engineering solutions that together created a qualitatively new machine. Morozov proved that designers should not think in terms of templates, but should start from the task at hand, even if it requires abandoning established traditions. The T-44 paved the way for tank construction in the second half of the 20th century. One of the key achievements of the T-44 was its improved torsion bar suspension. Morozov always paid great attention to the running gear, as it determines the mobility and survivability of a tank. The new torsion bars were longer and arranged in a special way, at an angle to the longitudinal axis of the tank. This made it possible to place more powerful torsion bars in a lower hull. The suspension ensured a smooth ride, dampened shocks when driving over uneven terrain, and allowed for accurate firing on the move. Large-diameter road wheels with rubber tires reduced the load on the tracks and the ground. The service life of the T-44's running gear was significantly longer than that of the T-34. The tank could travel thousands of kilometers without serious suspension repairs. This was critically important for deep offensive operations. The T-44's transmission was a masterpiece of engineering. Morozov managed to create a compact and at the same time reliable system for transmitting power from the engine to the tracks. The 5-speed gearbox provided flexibility in controlling the tank at different speeds and on different types of terrain. Planetary turning mechanisms made it easy to maneuver even at high speeds. Most importantly, control became much easier than on the T-34. The driver no longer experienced the physical strain of shifting gears. The control levers moved smoothly, with moderate effort. This reduced crew fatigue and increased the tank's combat effectiveness. The reliability of the transmission also increased. The parts were designed with a large margin of safety, high-quality materials were used, and precision machining was employed. The engine cooling system was designed with the new location of the power plant in mind. Radiators were placed on the sides of the engine compartment, which ensured effective heat dissipation. Cooling air was drawn in through louvers in the hull roof, passed through the radiators, and expelled through special openings. Fans forcibly pumped air through the cooling system. Even in hot weather, under maximum engine load, the coolant temperature remained within acceptable limits. Morozov took into account the experience of operating the T-34 in various climatic conditions, from the African heat to the Siberian frosts. The T-44 had to perform equally well everywhere. The engine lubrication system ensured oil supply to all friction pairs at any angle of inclination of the vehicle. The air cleaner reliably protected the engine from dust. The T-44's armor was not simply reinforced quantitatively. The very philosophy of protection had changed. Morozov applied differentiated armor, providing maximum protection to the most vulnerable areas. The front of the hull was a monolithic armor barrier, 90 millimeters thick, at a rational angle of inclination. The upper frontal section was at an angle of 60 degrees to the vertical, and the lower section was at an angle of 45 degrees. This design provided maximum shell resistance. Shells ricocheted off the sloped armor without penetrating it. The sides of the tank were also reinforced. 75 mm at the top provided protection against most anti-tank weapons. The rear had 45 mm of armor, enough to protect against shrapnel and large-caliber bullets. The T-44 used the same turret as the T-34-85, but Morozov was already working on designs for a new turret to accommodate a more powerful gun. The 85mm ZIS S-53 gun was a good weapon, but the appearance of heavily armored heavy tanks in the West required further reinforcement of the armament. Morozov considered installing a 100mm D-10T gun on the T-44, which could penetrate the armor of any existing tank. This gun required a new, even more spacious turret. Work on its design proceeded in parallel with tests of the basic version of the T-44. Morozov always thought ahead, incorporating opportunities for modernization into the design. This was a sign of the designer's maturity, creating not a fixed design, but a platform for development. The ergonomics of the crew's workstations in the T-44 were improved compared to the T-34. The driver got a more comfortable seat with adjustments, improved observation devices, and rationally located controls. The turret crew worked in a 3-seat turret with enough space for comfortable work. The tank commander had excellent all-around visibility through 5 periscopes in the commander's cupola. The gunner had a high-quality telescopic sight. The loader could quickly feed shells thanks to the rational placement of the ammunition racks. A radio station was installed on all tanks, which ensured reliable communication in battle. There was less noise and vibration inside the tank thanks to improved insulation of the engine compartment. All these details together made the T-44 a more effective combat vehicle than the T-34-85, despite having the same armament. Serial production of the T-44 began at the end of 1944, but the scale of production was limited. The war was coming to an end, production facilities were busy with the T-34-85, and restructuring production required time and resources. In total, less than 200 T-44s were produced before the end of the war. These tanks did not see action in the Great Patriotic War. They were being saved for the post-war army. But the significance of the T-44 went far beyond its quantitative contribution to victory. This tank laid the foundations for Soviet tank building in the second half of the century. The layout solutions applied by Morozov in the T-44 became classic for all subsequent Soviet medium and main battle tanks. Koshkin's student created a machine that was ahead of its time. On May 9, 1945, the Great Patriotic War ended. The Soviet Union had won victory over Nazi Germany, but at the cost of enormous sacrifices and destruction. Alexander Morozov, like the whole country, greeted this day with a deep sense of relief and pride. The tanks created under his leadership made a huge contribution to the victory. The T-34-85 became one of the symbols of the triumph of Soviet weapons. But the war ended, and the designer's work continued. The world was entering the Cold War era, and the Soviet Union needed modern armored vehicles capable of countering potential enemies. The T-44 was good, but Morozov was already thinking about the next step, a tank that would combine all the best qualities of the T-44 with more powerful weapons and further enhanced protection. Thus began work on the T-54, a machine that would define the Soviet tank forces for decades to come. The T-54 was designed as a major upgrade of the T-44 with the installation of a 100mm D-10T gun. This weapon was developed during the war to combat the heavily armored German King Tiger tanks. Its armor penetration was significantly superior to that of the 85mm gun. The shell could penetrate 170mm of vertical armor at a distance of 1,000 meters. This made the T-54 a dangerous opponent for any existing tank. But installing a more powerful gun required the design of a new, even larger turret. Morozov took on this task with enthusiasm. He created a hemispherical cast turret with armor up to 200 mm thick at the front. This turret provided excellent shell resistance thanks to the large angles of the armored surfaces. The hull of the T-54 was slightly modified compared to the T-44. It retained the same layout with a transverse engine and the same rational hull shape with sloped armor. The frontal armor remained at 90 mm, but this was sufficient to protect against most anti-tank weapons of the late 1940s. The main changes were the reinforcement of the side armor and the installation of a new, more advanced transmission. The 520-horsepower V-54 engine gave the 36-ton tank a top speed of 50 kilometers per hour. Its range reached 400 kilometers, which allowed it to conduct deep raids without refueling. The T-54 combined firepower, protection, and mobility at a level unattainable by Western tanks of the time. The first prototype of the T-54 was manufactured in 1945. Testing continued for over a year. Morozov demanded that the design be perfected. Defects were identified, changes were made, and retests were conducted. Morozov was in no hurry. He was creating a tank for many years to come, a machine that was to become the backbone of the Soviet Army's tank fleet. In 1947, the T-54 was accepted into service. Mass production began and continued for almost 20 years. The T-54 became the most mass-produced tank in history, with more than 85,000 vehicles manufactured. Morozov's tanks were used by the armies of dozens of countries and participated in conflicts around the world. Western experts acknowledged that the T-54 was superior to American and British tanks of the same period. The success of the T-54 brought Morozov well-deserved recognition. In 1946, he was awarded the Stalin Prize of the First Degree for the creation of the T-44. In 1948, he received a doctorate in technical sciences without defending a thesis. His tanks were the best proof of his scientific achievements. Morozov became one of the leading specialists in Soviet tank building, a recognized authority in his field. But he did not rest on his laurels. In the early 1950s, a new wave of tank improvements began. The advent of nuclear weapons changed the nature of warfare. Tanks had to operate on battlefields contaminated with radiation, overcome areas of chemical contamination, and protect the crew from the light radiation of a nuclear explosion. The T-54 required extensive modernization. The upgraded version was designated the T-55. The tank was equipped with a nuclear protection system, an automatic fire extinguishing system, and improved observation and aiming devices. The ammunition load was increased by removing the coaxial machine gun and reducing the crew to 4 people. The range increased to 500 kilometers thanks to the installation of additional fuel tanks. The V-55 engine developed 580 horsepower. The T-55 became an even more advanced combat vehicle than the T-54. Serial production began in 1958. In total, more than 50,000 T-55s were produced. Together with the T-54, these tanks formed the backbone of the armored forces not only of the Soviet Union, but also of its allies around the world. Morozov created a tank dynasty. But Morozov's most ambitious project was the development of a fundamentally new main battle tank. In the late 1950s, there was a shift in global tank design towards the concept of a single main battle tank that combined the functions of a medium and heavy tank. Such a tank had to have powerful armament capable of hitting any target, reinforced armor to protect against the latest anti-tank weapons, and at the same time maintain high mobility. Morozov saw the future in tanks with smoothbore guns, firing feathered sub-caliber shells, powerful diesel engines, and automatic fire control systems. In 1951, he returned from Nizhny Tagil to his native Kharkov, where he headed the design bureau of the Malyshev factory. Here, work began on the tank of the future. The year 1951 was a turning point in the life of Alexander Morozov. After 10 years of work in Nizhny Tagil, where he created the T-34-85, T-44, and T-54, he received an offer to return to Kharkov and head the tank design bureau of the Malyshev plant, the very same plant number 183, where his journey with Mikhail Koshkin began. For the 47-year-old Morozov, it was a return home to his roots. Kharkov had been rebuilt after the war and had once again become a major industrial center. The Malyshev plant produced T-54 tanks, but industry leaders saw Kharkov as a base for developing promising new generation technology. Morozov accepted the offer with enthusiasm. He understood that here, in Kharkov, where the T-34 was born, the tank of the future should also be born. A new chapter in his design career was beginning. The Kharkov Design Bureau for Mechanical Engineering had a proud tradition. Koshkin's colleagues worked here, and the atmosphere of creative exploration and engineering boldness was preserved. Morozov quickly gathered a team of talented young engineers around him. He was looking for people with unconventional thinking, capable of looking beyond the horizon and seeing the future of tank building. In the early 1950s, a revolution in military technology was taking place around the world. Guided missiles, jet aircraft, and nuclear weapons were appearing. Tanks had to adapt to the new realities of war. Morozov set his team an ambitious task: to create a tank that would be 20 years ahead of the world standard. Not just to catch up with the West, but to surpass it, to create technology that had no analogs. It was a grandiose goal, but Morozov believed in his team. In the mid-1950s, development began on a promising medium tank with the codename Object 430. Morozov incorporated the most advanced ideas into this project. The tank was to be equipped with a 115 mm smoothbore gun capable of firing sub-caliber projectiles with an initial velocity of 1,500 meters per second. Such a projectile could penetrate any existing armor. The tank's hull was designed with a minimum height of only 2 meters from the ground to the top of the turret. This made the tank a difficult target to hit. The armor was designed to withstand not only kinetic projectiles, but also the cumulative ammunition of anti-tank missiles. A 700 horsepower engine provided a speed of up to 70 kilometers per hour. The crew was reduced to 3 people thanks to automated loading. It was the tank of the future. Work on Object 430 proceeded slowly. Many technical problems had to be solved. The smoothbore gun was a fundamentally new type of tank weapon. It was necessary to develop ammunition, guidance systems, and a loading mechanism. The armor had to protect against new types of threats, high explosive shells and missiles. Morozov proposed using combined armor with several layers of different materials. It was a revolutionary solution, but it had to be worked out and tested. The fire control system required electronic computing devices to automatically take into account the range, speed of the target, and weather conditions. Soviet electronics in the 1950s was just beginning to master these technologies. Each component of the tank required research, experimentation, and testing. In parallel with the futuristic Object 430, Morozov worked on a more realistic project. In 1957, the military leadership set the task of creating a main battle tank that would combine the functions of medium and heavy tanks. Such a machine was to have the armament and armor of a heavy tank, but the mobility and dimensions of a medium tank. Morozov proposed a bold project to install a 124mm rifled gun on a relatively compact 36-ton hull and provide anti-shell armor by using rational angles of inclination for the armor plates. The project was designated Object 432. It was the direct predecessor of the legendary T-64. Work on it was carried out intensively. Object 432 embodied the design philosophy that Morozov had developed over 20 years of work. Maximum compactness with maximum combat power. Transverse engine layout, rational armoring, powerful armament, automation of processes. Morozov used an automatic loading system which allowed the crew to be reduced to 3 people. This reduced the size of the turret, lowered the overall height of the tank, and reduced its weight. The freed-up weight was used to reinforce the armor. The 5 TDF engine with a capacity of 700 horsepower was specially developed for this tank. It was an opposed 5-cylinder 2-stroke turbocharged diesel engine, a fundamentally new design, very compact and powerful. The transmission was also redesigned to accommodate the increased engine power. The creation of Object 432 required the solution of many complex technical problems. The automatic loading system had to work flawlessly in all conditions, during heavy rocking, in the cold, in the heat, and after long storage. Morozov personally supervised the testing of the automatic loading system, striving for absolute reliability. The new engine required debugging. The 2-stroke design was unusual for tank engines, and there were problems with cooling, lubrication, and starting in cold weather. Engineers worked day and night to eliminate the shortcomings. The fire control system included a ballistic computer, a 2-axis weapon stabilizer, and a laser rangefinder. This was a breakthrough in the field of tank electronics. Gradually, step by step, the design matured. By the early 1960s, Object 432 was ready for state testing. Morozov understood that he was creating a tank that would determine the development of Soviet tank building for decades to come. It was a huge responsibility, but also a great opportunity to put his accumulated experience and knowledge to use. He was already over 50, but he had the energy and enthusiasm of a young designer. He continued to work 12 to 14 hours a day, delving into every detail and demanding maximum effort from his subordinates. Under his leadership, the Kharkov Design Bureau became one of the world's leading centers of tank construction. Western intelligence services tried to uncover the secrets of the new Soviet tanks, but without success. The secrecy regime was strict. The world would learn about Morozov's tanks later, when they had already become a formidable weapon of the Soviet army. Meanwhile, intense work continued, bringing the new tank's birthday closer. In the early 1960s, Object 432 passed state tests and was recommended for adoption into service. The tank was given the Army Index T-64. It was a revolutionary breakthrough in global tank building. Alexander Morozov created the world's first main battle tank with an automatic loading system, combined armor, and an opposed-cylinder turbocharged diesel engine. The T-64 was 10 to 15 years ahead of Western developments. No NATO tank at that time could match it in terms of overall characteristics. The 124mm D-81 smoothbore gun, later replaced by the D-81T and then the 125mm 2A46, could penetrate the armor of any existing tank from a distance of over 2 kilometers. The combined armor provided reliable protection against kinetic and cumulative shells. The automatic loading system ensured a firing rate of 8 rounds per minute, regardless of the gun's position. The three-man crew was accommodated in a minimal space. The tank was only 2 meters 22 centimeters high. The T-64 became the benchmark for others to emulate. The adoption of the T-64 into service in 1964 was a triumph for Morozov and his team. But it was not just the success of one designer. It was confirmation of the correctness of the entire Soviet school of tank building, founded by Koshkin and developed by his student. The transverse engine layout, first used on the T-44, became the standard. The rational armor with sloped plates, invented for the T-34, reached perfection in the multi-layered composite armor of the T-64. The diesel engine that Koshkin fought for became the compact and powerful 5TDF. Every technical element of the T-64 had its own history, rooted in pre-war and wartime developments. Morozov did not reject tradition. He developed it to a level that seemed fantastic. Serial production of the T-64 began at the Malyshev plant in Kharkov. It was a technologically complex tank that required highly skilled workers and precision equipment. The automatic loading system was a complex electromechanical complex that required careful adjustment. The 5TDF engine was capricious in operation and required high-quality maintenance. The fire control system included electronic components that were sensitive to vibrations and temperature changes. The first mass-produced tanks had teething problems that required refinement. Morozov personally supervised the debugging process of mass production and insisted on the elimination of all shortcomings. Gradually, the reliability of the T-64 increased, and the tank became a mature combat vehicle. By the end of the 1960s, the T-64 had become the backbone of tank divisions deployed in key areas. Western military experts found it hard to believe the T-64's specifications. When NATO intelligence first received information about the new Soviet tank, many considered it to be disinformation. It seemed incredible that the USSR could create a tank weighing 38 tons with the armament and armor of a heavy tank. The automatic loading system was considered technically impossible. Combined armor was unknown to Western designers. When the information was confirmed, NATO launched an urgent program to develop a new generation of tanks. The T-64 forced the West to rethink its tank design concepts. The American M60, British Chieftain, and German Leopard 1 were hopelessly outdated even before their mass production was completed. Morozov had managed to create the tank of the future. The success of the T-64 earned Morozov the highest state awards. In 1967, he was awarded the title of Hero of Socialist Labor. He became a laureate of the Lenin Prize and received numerous orders and medals. But the main reward for the designer was the recognition of the tank crews. The T-64 crews noted the power of its weapons, the reliability of its protection, and the ease of working in the tank. The automatic loading system freed them from heavy physical labor and allowed the crew to focus on combat. The fire control system ensured high firing accuracy. The T-64 became the favorite tank of Soviet tankers. Morozov received letters of gratitude from the units where his tanks served. This inspired him to continue his work. But Morozov did not rest on his laurels. While debugging the T-64, he worked on its extensive modernization. The emergence of new anti-tank weapons, guided missiles with tandem warheads, sub-caliber shells with uranium cores, required further strengthening of defenses. Morozov developed options for dynamic protection, active missile defense, and reinforced combined armor. The armament also needed improvement. The 125mm smoothbore 2A46 gun became the standard for Soviet tanks. New ammunition with increased armor penetration was developed. Morozov worked on projects for tanks with 150mm guns, unmanned turrets, and fully automated control systems. Some of these projects remained on paper, while others were partially implemented in prototypes. By the end of the 1960s, Alexander Morozov was recognized as the patriarch of Soviet tank building. He was 65 years old, but he was still full of creative energy. Under his leadership, the Kharkov Design Bureau became a training ground for the entire tank industry. Many of his students headed design bureaus at other factories, continuing the traditions of the Koshkin-Morozov school. A dynasty of Soviet tank builders was created, united by common design principles and a common approach to the creation of combat vehicles. Morozov generously shared his experience, teaching young engineers not to be afraid of bold decisions, to look for non-standard solutions, and to always remember that a tank is created for people, for the crew that will fight in it. This humanistic approach distinguished Morozov from many other designers. He did not create abstract technical devices, but comrades in arms for tank crews. In the 1970s, Morozov's health began to deteriorate. Decades of intense work, stress, and overload took their toll on his body. But he continued to head the design bureau and oversee the development of promising projects. The last major project under his leadership was the Object 476 tank, which was to be a further development of the T-64. Morozov put all his experience and accumulated knowledge into this project. He wanted to create a tank that would serve the Soviet army until the end of the 20th century, but he was not destined to complete the work. On June 15, 1979, Alexander Alexandrovich Morozov died in Kharkov at the age of 74. A great designer who created tanks that defined the appearance of armored forces for half a century passed away. But his students continued his work, and the tanks continued to live on, protecting the country. Alexander Morozov did not just create tanks. He created a school of Soviet tank building. A whole generation of talented engineers grew up around him, who continued his work, developed his ideas, and carried his principles into the future. This was the second generation of Soviet tank builders who replaced pioneers such as Koshkin, Kotin, and Ostrov. If the first generation laid the foundations, the second brought them to perfection and opened up new horizons. Among Morozov's students were the designers who created the tanks of the 1970s and 1980s, vehicles that determined the balance of power in the Cold War. The Kharkov School of Tank Building, founded by Koshkin and developed by Morozov, became one of the world's leading schools. Its principles were studied, imitated, and competed with. But for a long time, no one was able to surpass it. The main principle of Morozov's school was rationality. Every gram of a tank's mass must contribute to its combat effectiveness. No excesses, no showmanship, only what was necessary to accomplish the combat mission. Compactness, high specific power, powerful armament, rational armoring, these principles ran like a red thread through all the projects of Morozov and his students. Soviet tanks were always smaller and lighter than their Western counterparts, with comparable and often superior characteristics. This was achieved not by compromising the crew's working conditions, but through engineering excellence in design. Each component was designed with the utmost care, and every decision was calculated and verified. Morozov taught A designer must be stingy with mass and generous with ideas. This philosophy defined the appearance of Soviet tanks. The second most important principle was manufacturability. Tanks had to be produced in large quantities, quickly and relatively cheaply. Morozov remembered the lessons of war. When thousands of vehicles are involved, manufacturability becomes a critical factor. He always designed tanks with mass production in mind, using casting and stamping instead of complex machining, standardizing components, and simplifying assembly. The T-34 was a technologically advanced tank for the 1940s, the T-54 for the 1950s, and the T-64 for the 1960s. Each represented the pinnacle of technological capabilities of its time. Morozov's students continued this tradition, creating tanks that could be produced in the thousands without a critical decline in quality. The third principle was reliability and maintainability. A tank must operate in the most difficult conditions, in the desert and the Arctic, in mud and dust, after months of storage and after days of continuous movement. It must be easy to repair by the crew in the field. Morozov taught people to think of a tank as a living organism that not only needs to be born, but also raised and ensured a long life. Diesel engines, torsion bar suspension, and a simple and reliable transmission all ensured the survivability of the tanks. Soviet machines were renowned for their ability to operate in conditions where Western tanks would break down. This was Morozov's legacy, his understanding that technology is created for war, not for exhibitions. The fourth principle is continuous improvement. Morozov never considered his tanks to be final. The T-34 underwent dozens of modifications during the war years. The T-54 was improved over a period of 20 years. The T-64 received numerous improvements after it was adopted for service. A designer must think decades ahead, build in room for modernization, and anticipate the direction of military technology development. Morozov taught his students not to be afraid to rethink their own decisions, to seek better options, and to learn from their mistakes. This flexibility of thinking allowed Soviet tank building to remain at the forefront for decades. While the West was creating tanks for specific requirements of the moment, Soviet designers were thinking about the future. Morozov's students went to different design bureaus and headed projects for new tanks. In Leningrad, the T-72 was created, a mass-produced main battle tank that was simpler and cheaper than the T-64 but retained its main advantages. In Nizhny Tagil, the T-90 was developed, a further development of the T-72 line. In Omsk, experimental tanks with gas turbine engines were being designed. The Kharkov Design Bureau continued the T-64 line, creating its deep modernizations. All these machines bore the stamp of Morozov's school: compactness, powerful armament, rational armor, and high mobility. The differences were in the details, in the technological solutions, and in the level of automation. But the philosophy remained the same. This was the school of Soviet tank building. By the end of the 1970s, the Soviet Union had the most powerful tank fleet in the world. Tens of thousands of modern combat vehicles were in service with the Soviet Army and the armies of the Warsaw Pact countries. Soviet-made tanks were exported to dozens of countries and participated in conflicts on all continents. The Arab-Israeli Wars, the Indo-Pakistani conflict, the wars in Africa. Everywhere, Soviet tanks demonstrated high combat effectiveness. Western military experts acknowledged that the USSR had achieved technical superiority in tank building. This superiority was the result of the work of 2 generations of Soviet designers. The first generation, led by Koshkin, created the revolutionary T-34. The second generation, led by Morozov, brought the revolution to its logical conclusion by creating a family of main battle tanks that were unmatched in the world. Morozov lived to see the fruits of his labor. In the last years of his life, he watched his tanks serve the army, his students create new machines, and Soviet tank building maintain its leadership in the world. This was the best reward for a designer who had devoted his entire life to his work. He began his career as a young clerk at the Kharkov plant in 1919. He went through war, evacuation, and decades of hard work. He created tanks that defended the motherland in the most difficult years and ensured its security in peacetime. He raised a generation of designers who continued his work. The mission was accomplished. The student surpassed the teacher, as it should be. Koshkin created the T-34, which changed the course of the war. Morozov created the T-64, which changed the face of post-war tank building. The baton was passed from one generation to the next. The school lived on and developed. Alexander Morozov's legacy extends far beyond the tanks he created. He left behind a school of thought, a design philosophy, and a tradition of engineering excellence. The Kharkov Design Bureau, which he headed for a quarter of a century, continues to create armored vehicles based on the principles laid down by Morozov. The T-64, T-80UD, and BM Oplot tanks carry the DNA of Morozov's machines: compactness, power, and rationality. Even modern 21st century tanks use technical solutions first applied by Morozov 60 years ago. The transverse engine layout, automatic loading system, and combined armor are all still alive and evolving. The designer did not just create machines, he created a direction for the development of tank building for the next century. The T-64 became the progenitor of a whole family of Soviet and Russian main battle tanks. It was used as the basis for the T-80 with a gas turbine engine, the world's first mass-produced tank with such a power plant. The Kharkov Design Bureau developed the T-64A with enhanced armament, the T-64B with the ability to fire guided missiles through the gun barrel, and the T-64BV with mounted dynamic protection. Each modification was a step forward, a development of Morozov's ideas. In the 1990s, the BM Oplot appeared, a deep modernization of the T-64 with a modern fire control system, reinforced protection, and improved characteristics. This machine proved that Morozov's reserve for modernization was truly enormous. A tank from the 1960s was able to survive into the 21st century and remain combat-ready. Morozov's influence also spread to foreign tank manufacturing. When Western intelligence services obtained detailed information about the T-64 in the 1970s, it caused a shock in NATO military circles. It turned out that the Soviet Union was a decade ahead of the West in tank construction. Urgent development of a new generation of tanks began. The American M1 Abrams, the German Leopard 2, and the British Challenger. All these machines were created with Soviet experience in mind, as a response to the challenge posed by the T-64. The automatic loading system, mastered by the French on the Clerk tank, combined armor, which became the standard for all modern tanks, and a compact layout. All of this was first implemented by Morozov. The Soviet designer determined the direction of development for global tank construction. Morozov's personality was an example for several generations of Soviet and Russian engineers. Modest, demanding of himself and his subordinates, devoted to his work to the point of self-forgetfulness. This is how his colleagues remember him. He never boasted about his achievements, or sought personal glory. His entire life was devoted to work. Even in his later years, when his health no longer allowed him to work with the same intensity, he came to the design bureau, advised young designers, and shared his experience. For him, design was not a profession. It was a calling, the meaning of life. Morozov embodied the best qualities of a Soviet engineer: talent, hard work, patriotism, and selfless dedication to his work. His example inspired thousands of people to choose engineering professions and devote themselves to the creation of technology. The memory of Morozov lives on not only in tanks. The Kharkov Design Bureau, which he created, bears his name. A monument to the great designer has been erected in Kharkov. Streets in several cities are named after him. Books have been written about him, and documentaries have been made. But the best monument to Morozov is the tanks that are still in service, defending the country and serving the people. The T-64 and its descendants continue to serve in the armies of several countries. They have been through real wars and proven their effectiveness in combat. They have saved the lives of thousands of tankers thanks to their reliable protection and powerful armament. Every tank crew member who has returned safely from battle is a monument to the designer who created this reliable machine. Morozov's path from clerk to creator of the tanks of the future is a story of how talent, hard work, and dedication can change the world. He did not have a higher education in his youth and started from the lowest positions, but his perseverance, curiosity, and ability to learn brought him to the top of his profession. He became a doctor of science, a hero of socialist labor, and a laureate of the highest awards. But most importantly, he became a designer with a capital D, a man whose creations outlived their creator and continue to serve decades after his death. This is true immortality: to live on in your creations, in your students, in the traditions you have created. The connection between Mikhail Koshkin and Alexander Morozov is a beautiful story of generational continuity. The teacher created a revolutionary tank that changed the course of the war. The student perfected the revolution and created the tanks of the post-war era. Koshkin laid the foundations, Morozov built the edifice of Soviet tank building on them. Together, they span the period from 1937 to 1979, more than 40 years of continuous development, creativity, and exploration. During these years, Soviet tank building went from experimental machines to world leadership. And throughout this journey, two names went hand in hand: Koshkin and Morozov, teacher and student, genius and his successor. Two lives devoted to one cause, two designers who created the tank power of a great country. Alexander Alexandrovich Morozov died on June 15, 1979. He was 74 years old. He lived a long, meaningful life. He lived through the Revolution, the Civil War, industrialization, the Great Patriotic War, and the Cold War. He saw how the country changed, how technology developed, how his tanks defended the motherland. He created machines that saved millions of lives. He raised a generation of designers who continued his work. He surpassed his teacher by fulfilling the covenant made on Koshkin's deathbed. The mission was accomplished. The baton was passed on. The school continued to live on. The tanks continued to defend. And the memory of the great designer continued to inspire new generations of engineers to creative feats. The student surpassed the teacher. And in this lies the highest meaning of generational continuity.